Hi, good afternoon and good evening, people. This is TezAsia Hackathon. Today is workshop day number 2, and we have a guest on board with us. He's Mr. Moody, and he is a blockchain technology analyst from Tezos, India. So he will be taking with you through two of the workshops, which are the fungible tokens on day one, which is today, and tomorrow will be the non-fungible token. So I would like to pass the on the screen time to Mr. Moody so that he can conduct his workshop. Thank you very much.
All right, hi everyone. I'll start sharing my screen. I hope you guys can see my screen now. Right, I'll kick off quickly. Oh, sorry. All right, so fungible tokens on Tezos. We'll be looking at FA1.2 and FA2, and we'll touch upon what these mean. But yeah, we'll primarily be looking at fungible tokens, and we'll also touch upon what fungible tokens are today. So start off with a brief introduction about what blockchains are, what smart contracts are, what is Tezos, and what is consensus, and in particular the consensus used by Tezos. All right, so a blockchain is an immutable, tamper-evident shared digital ledger that records transactions in a peer-to-peer network. So basically, it's a chain of blocks that are tied together using cryptographic hashes, which make it immutable and tamper-evident. And since it is shared across uh, peers in a peer-to-peer network, across nodes in a peer-to-peer network, it's a shared ledger which adds further tamper resistance and further immutability. So this is what a blockchain looks like. There are different blocks which are tied together using hashes of the previous blocks, and each block has some metadata, which is things like the timestamp, the block number, the block hash, the creator of the block producer, stuff like that, and the actual data which contains the transactions that are included in the block. Uh, the blocks are produced using consensus, and there are different mechanisms of consensus, how a peer-to-peer network will arrive at consensus. We'll not go deep into it because this is not what we are dealing with. Uh, Smart contracts are programmable, self-executing piece of code that live over the blockchain, and they dictate terms of contract like a regular contract. They dictate terms of a contract or an agreement between parties that are involved in the smart contract. The reason blockchains use smart contract is so that they can extend the functionality of the chain and provide trustless program execution. So yeah, that's a bit about smart contracts. This is a quick example. I'm not going to touch this too much. Tezos is now we look at what Tezos is. So I mean, I haven't gone into the depth of blockchain and smart contracts because the assumption is that you know blockchain and smart contracts. Yeah, yeah. So that's the premise of the presentation. So Tezos is basically an open source blockchain infrastructure. It's also a dApp platform or a smart contract platform. So you can use Tezos to build your decentralized applications, which are one or more smart contracts, and it has a couple of cool features like on-chain governance and a way to formally verify smart contracts. So these are important features. Now, for the smart contracts aspect of Tezos, the smart contracts are uh, written in, I mean, compiled at least in and executed in a language called Michelson, which is a domain specific, a very low level domain specific stack based programming language. So I hope you guys know what stacks and queues are, you know, how stacks work. So it's a very low level language in the sense that it's closer to machine assembly code than it is to, you know, human readable code. Um, Similar to, I mean, basically like C is a very low level language and maybe Python is a high level language, right? So this is even much lower than C. It's similar to like assembly code that you would see, or opcodes, basically string of opcodes. Yeah. So it's domain specific, meaning that it is used just for Tezos smart contracts and doesn't have a use case beyond that. Another salient feature of Tezos smart contracts is that they support what is known as formal verification of contracts, and which is very important to prevent bugs. I mean, I think just yesterday there was a major hack on one of the DeFi protocols in Ethereum, where about some $600 million worth of ETH and other assets were stolen, right? So this is because there are bugs that are left in or that exist within smart contracts, especially DeFi protocols, which, if not formally verified, are potentially hazardous to the degree that was seen yesterday. Um, so yeah, that being said, it also supports high-level languages like SmartPy and Lego against writing directly in Michelson, which is a little cumbersome and difficult to write for the average programmer. So we'll look at that in just a bit. Consensus. Now, the consensus that is used by Tezos is called liquid proof of stake, or more recently, it's called ME+. It's basically a Nakamoto style proof of stake algorithm, where with delegation. Uh, so therefore, the delegation aspect makes it liquid proof of stake. The block creation process is called baking, and the block producers or block validators are known as bakers. So the validators in the system perform the function of baking or validating based on their stakes. And every time a new block is added, it is added by a random validators selected amongst these group of validators, again based on stake. And then this random block is validated and authenticated or endorsed by 32 other random validators. So a diagrammatic representation will make it easier. So let's say there are 1,000 bakers. To become a baker, let's say you have to stake a minimum of 10,000 Tezos or XTZ. Ignore the spelling, it's XZT, but it's actually supposed to be XTZ. So a baker will, amongst the 1,000 bakers that are there, the protocol will choose 32 random bakers, of which one will be chosen as the producer, the block baker, the the block producer, and the others will be validating the block that is produced by this baker. There is also delegation, which makes the protocol liquid and the consensus liquid, in the sense that the delegate can different people who hold Tezos can delegate their Tezos to a baker that they trust, and the baker block, bakes the blocks and validates blocks, and whatever rewards it gets, it shares with them based on certain, based on his or her uh, fee mechanism, right? So that's how baking works. Now, that being said, so that's basic introduction. If you guys have any questions, I would uh, urge you to stop me time and again. All right, so um, yeah, so now fungible tokens. The fungible tokens are basically, so a blockchain is basically very handy for tokenizing assets. So any assets can be put on the blockchain. When we say assets are put on the blockchain, it means that these assets are tokenized, and these token representations of these assets are put on the blockchain. All right, so that's what it means when we say assets are put on the chain. So these tokenized assets are called tokens, obviously, and the most basic form of tokens are fungible tokens, which come from tokenizing what are known as fungible assets. And these tokens or these assets are a class of interchangeably usable identical assets or tokens. All right. For instance, you can take, for instance, a US dollar or a Singapore dollar or an INR. All right. So one INR is equal to always equal to one INR. So if I have an Indian rupee and you have an Indian rupee, it's the same. If I have a note of Indian rupee and you have a coin of Indian rupee, it's the same. If I have 1 rupee here in my wallet and if I have 1 rupee in my bank account, they're both same. They're interchangeable, right? No matter what. So that's a fungible asset is. So currency is a very good example. So Tezos XTZ, the native currency of Tezos, is also a fungible asset. And many times we need fungible assets to work with use cases like, especially in cases related to money, right, in finance. So there are two main token standards that we're going to look at, as we mentioned, FA 1.2 and FA2. So FA 1.2 or Financial Application 1.2 refers to this standard for smart contracts which implement token ledgers on the blockchain, and it is an ERC20 like fungible token standards for Tezos. For those of you who are coming from an Ethereum background, it is similar to an ERC20 token standard. So FA 1.2 is similar to ERC20, and the specifications, as in ERC20, the specifications are already given out in EIP. So similarly here, the specifications are specified in what are known as TZIPs or Tezos Improvement Protocols, and this one is described in TZIP 7. All right. So an FA2 compliant smart contract implements a ledger that maps owners to account balances and offers entry points which are both stateful and stateless. That means that they alter the state and they just read data or view data. So these entry points are used to get balances, to transfer, to approve transfers, to maintain a lot of stuff. So yeah, so this is what an so whenever whenever we're going forward, we say FA2 contract, we would actually mean a smart contract that satisfies the FA 1.2 standard or that is compliant with FA2 1.2 standard. All right. So yeah, FA 1.2 as such implements it implements multiple entry points that describe, as we discussed, how users can transfer tokens, how they can approve others to withdraw tokens on their behalf from their account, and retrieve information about tokens like balances, withdrawal allowances. I mean, how much is someone allowed to withdraw on my behalf from my account, and what is the total supply at the moment, things like that. So an FA2 compliant smart contract or a simple FA 1.2 contract has at least these 5 entry points. The first is transfer, which expects a from account, a to account, and the amount of tokens that need to be transferred. And it does the transfer and updates the ledger accordingly. Of course, you would need to own those many number of tokens. So it's a stateful transaction, and it is different from ERC20 being a batch transaction, whereas in ERC20 it's a singular transaction. Also, another major difference is that in ERC20 you've got transfer and transfer from, right? Here you don't need a transfer, and I mean both of them are coupled into a single transfer function. Next up, you've got an approve function, which expects an owner, a spender, and a new allowance for the spender and updates the approvals. So approvals are basically maps or big maps that are stored on the FA 1.2 contract. And the approve function lets users alter the approval or the allowance that a sender can spend from their account on their behalf. Yeah, so that's basically the approve function. It's also a stateful function. The other 3 functions are stateless functions or view functions. So the first one is get balance, which expects an owner and returns via callbacks. So all of these getter functions are not like the Ethereum view or pure functions. They're different. They work with a callback, and they return the owner's balance. All right, that's the get balance function. Similarly, the get allowance takes an owner and spender and returns the approved allowance for the spender. And the get total supply again does not expect anything, returns the total sum of balances. I mean, the total supply within the ledger. Of course, these are the 5 basic entry points that a contract must implement, but these are no way like all the entry points. It's not exclusive. You can have other entry points, like you can have entry points for burning, minting tokens, or for managing administrators, for managing operators. Yeah, but just having these 5 ensures that the contract is FA 1.2 compliant, right? So you've got different implementations of FA 1.2 on Lego, SmartPy, and Lawrence. For the purpose of this, we are going to be looking at the SmartPy one briefly. Just going to see if there are any questions at this moment. Okay, I don't see any questions. All right, just give me a second. All right. Sorry, I had to switch my screens. Yeah. Yeah. So FA 1.2 have three different implementations on different languages. So if you remember, we just spoke of when we spoke of Tezos, we said that Tezos ultimately the code is written and compiled in Michelson. Which is a low-level language specifically used for Tezos, and but of course it's a hard language to master and to understand. So you can use languages like SmartPy and Lego. So here you see that FA 1.2 is also implemented in these languages. Um, so yeah, I see a question in the chat which is, could you please explain about LPOS, baking and delegation? For sure, yeah, I can do that. For that, I would actually just quickly touch upon what consensus is. Uh, so a blockchain, as I said, is a peer-to-peer network, right? Uh, um, it uses or the blockchain network is a peer-to-peer network in which the blockchain itself, the data structure or the ledger is distributed across the member nodes, right? And how every time a new block is created, it gets appended. So it's an append-only ledger. So every time a new block is created, it gets appended to the ledger, right? So how do different peers or different nodes arrive at consensus about which block is a valid block and which transactions are valid transactions? So that is where consensus comes into play, right? How do these different peers in the network agree on which block is correct and whether or not the block producer is proposing correct transactions or malicious transactions. That's the idea of consensus. There are different consensus mechanisms like proof of work, proof of stake, proof of authority, proof of history, and so on and so forth, and proof of stake. So what Tezos uses is called as proof of stake or liquid proof of stake, or more recently ME plus. The idea is this: I stake certain tokens. I'm trying to explain to you what a proof of stake is, and then we'll come to liquid proof of stake. So proof of stake, the idea is very simple. Instead of doing computation work as I would do in something like in something like Bitcoin or the current Ethereum state mechanism, where I would do computational. I will solve computational puzzles and spend computational power to prove that I've actually found the correct block which solves the puzzle, and therefore prove that the block is indeed correct. So instead of doing that, what I do is I stake certain amount of Tezos, for instance. All right, let's assume that Tezos is a proof of stake chain. So I would stake a certain amount of Tezos, and I would propose a block as based on my stake. So the more I stake, the more my chances are of getting selected. And if I get selected, and if I bake a block or if I create a block, I get a reward, right? So I get incentivized. So that is why I would want to stake more. The more I stake, the more I am, the more the chances are for me to get selected to create a block, and the more my chances are, the more I create blocks, the more incentives I get, right? So that is why I would stake more. So the idea is if in case I propose a block that has malicious transactions, or if I propose malicious transactions, maybe like double spends or incorrect balances, and if someone else is able to prove that the transactions that I put together are double spending or malicious, what happens is my stake gets slashed, right? This is what it's called. My stake gets taken away. It gets slashed, all right. And this slash stake is handed out to whoever whoever presents a proof that I cheated, all right, or at least a part of it is, all right. So it incentivizes people to report bad actors, to report malicious actors, right? And this is what the validators do. So the validators, if you look at this, the validators are actually supposed to verify and validate a block, authorize a block, saying that all right, this block is correct. If any of those is able to find an issue with the block, then they get the reward, right? So this is basically the consensus mechanism. Just give me 1 second, guys. Yeah. So now this is the baking aspect where random block producers or validators are chosen to validate a block, and one validator is chosen to bake a block, or he's the baker of that particular cycle. And The delegation aspect is very simple. So there is a minimum amount of Tezos that needs to be staked to become a baker, right? That could be 10,000 XTZ. Let's assume that it is 10,000 XTZ at the moment. All right. Let's say I have all the infrastructure that is needed to become a baker, but I don't have 10,000 XTZ. What I can do is I can crowdsource this. So I can open up my pool and I can ask people to delegate their XTZ for me. All right. Or let's say even if I have 10,000 XTZ, the more I have, the more chances I have, right, of being able to bake a block, right? So I can just call out for different uh, individuals who hold XTZ, who can hold less or more than 10,000, right? They could themselves potentially be a baker, but they don't want to get into the hassle of baking a block. So they just want to delegate their XTZ in order for passive income, right? So that's the idea. So they delegate their stake to a baker. The baker bakes the block, and they get rewarded uh, based on the agreement that the baker and the delegator has, or the delegate has. So that's the idea. Does that answer your question? So I'll move on. If it doesn't, or if it does, either ways, please do let know. All right, so that was FA 1.2, which is an ERC 20 like standard. Now we look at FA2, which is a financial application 2, which is a standard for what is known as a unified token contract interface. It supports both a wide range of token types and implementations. Example: fungible, non-fungible, non-transferable, transferable. So different types of implementations and token types are supported. It also supports single asset types or multi-asset types. So it's very similar to the ERC 1155 standard that you see on Ethereum. And yeah, so the specifications of FA2 are specified in the 12th TZIP, or the TZIP 12. And the behavior of the token, as I said, is controlled by a set of values which are passed during initialization, like single asset, non-fungible, and assume consecutive token IDs. I will briefly touch upon these as well. So basically, to use an FA2 as a fungible, so FA2 is basically a multi-asset contract, right, or a unified token contract. So you can use it for any type of token standard. It's very customizable, but with great flexibility comes great uh, complexity, I'd say. So that's my attempt to uh, to tailor the famous Spider-Man uh, dialogue. But the idea is, since it is a very customizable token standard, it might get a little overwhelming. It's not as simple as FA 1.2, and to provide more flexibility, more customizability, it becomes more and more complicated to support all of those cases, all of those use cases. All right. So the same contract can be used to work like a single asset or a multi-asset, fungible, non-fungible, uh, and so on and so forth. Right. You just need to turn on and turn off certain flags within the initialization. So the FA2 again has certain entry point requirements that make it FA2 compliant. Again, when I say an FA2 contract, what I mean is a contract that adheres to, or that complies with, or that satisfies the specifications that are laid down in the TZIP 12 or in the FA2 standard, right? So I'm going to just use FA2 contract, right, or an FA2 compliant smart contract. So it has the following three, at least the following three entry points: transfer, balance off, and update. An important thing to note is that in FA2, all the operations are batch operations, as against in FA 1.2, meaning that they allow multiple transfers of different tokens of the same token and of different token types to be executed in one atomic transaction. So an atomic transaction, I hope you guys know about databases and what atomicity is and what atomic transactions are. So an atomic transaction is basically a group of sub transactions. If one fails, all of them are rolled back. So now we look at transfer. So transfer expects a from account and a list of transaction objects. So this is like an array or a list. Each contains an account, a token ID, and an amount of tokens that need to be transferred from that from account to that particular to account within that object. What it does is it iterates through all these transactions within the transaction object and checks that the transfer request is valid against the policy. They have enough balance and the policies are met, and then does an atomic transaction with all of these transfers, or rolls back if any of these fails, right? So it rolls back all of this. Again, this is a stateful transaction. The second of importance here is balance of, which again, being a batch operation, expects a list of request objects, and each request object consists of owners with token IDs, and now taking this as a request object, it returns a list of balances along with the corresponding request. So basically, you would provide a list of object. Each object would contain an owner and token ID, and it would in response give you a list which would have a balance along with the request object. The next entry would be the balance along with the request object. Balance request object, balance request object, right? That's how it would work. So the following is an implementation of FA2. This is a mistake, typo here. So it's an implementation of FA2. Implementations, all right. So now coming to implementation, there are multiple classes. So okay, for the purpose of this, I'm looking at this from SmartPy perspective because according to me, SmartPy does the simplest implementation and it's easiest for me to use. So I would suggest all of you to also check out SmartPy. All right, I see another question. I'll just stop here for a bit and then come back to implementation. So question from Vijay. Does 51% attack threat exist for Tezos blockchain? How does LPOS different from, okay. So 51% attack, yes, I mean, it exists in almost all blockchains. So any chain where, I mean, if you have 51% of the stake, all right, let's say you have 51% of the stake, all right. So your chances of getting selected are very high. And I mean, more often than not, you would be the chosen, block producer. So, but it's very hard to hold 51% of all the Tezos in the world. I mean, there is a Tezos Foundation that ensures that no such party gets so much of funds of Tezos at any point, and they sit on a lot of Tezos themselves. So it would be almost impossible to do that in a network like Tezos. But of course, technically, theoretically, it is possible. How is liquid proof of stake different from delegated proof of stake? In delegated proof of stake, there are certain delegates who are pre-chosen to produce blocks. For example, a blockchain like EOS is a DPoS blockchain, in which 100 block producers are chosen beforehand to produce blocks. All right, the count is fixed here. The count is not fixed here. Anybody who has a minimum amount of 10,000, which in our example was 10,000, anyone who has a minimum amount of Tezos can stake it and become a baker. So there is no limit to how many bakers can exist. All right. The more the number of bakers, the securer the network is. So that's one. Another difference is that it is liquid in the sense that people can delegate to these bakers rather than these delegates producing blocks. All right. So I can delegate whenever I want. I can take that out whenever I want. All right. So that makes it liquid. Another difference is it is unpredictable. I mean, who gets chosen to bake a block is random, whereas in DPoS, at times it is a round robin mechanism that is chosen to to dictate who's going to produce a block. So it makes it slightly less secure. So those are the differences. Hope that makes sense. Another question from Vijay is, could you please tell me more about 1155 and compare it with FA2? Vijay, I would love to answer that question, but I'll do that tomorrow because today we are focusing on the fungible token aspect and not on the token comparison. Although they're very similar, the FA2 has some advantages, some modifications, but as I said, the more customizability brings more complexity, so it's slightly more complex. But yeah, it's pretty much similar. So that's the idea. Yeah, sorry. So implementation, uh, these contracts are executed or implemented as different classes. So the first class is a core class, which is an FA2 core or an FA1.2 core, which basically contains the core functions that are needed for the contract to be FA 1.2 or FA2 compliant, right? So the three functions here or the five functions here form the core class, all right? The second class is a config class, which takes in different flags. So like whether or not you want your basically they make the asset contract or the token contract more configurable, all right? So you can configure whether it'll be a fixed supply or a mintable, burnable, or whether it'll be a pausable, or whether it'll have administrative functionalities, or whether it'll have an ability to modify the metadata, or the ability to or whether it'll be a single asset or a multi-asset, or whether it'll be fungible or a non-fungible. So basically, it makes the entire contract very configurable. All right. Um, Next is admin, or okay, let's look at metadata. So the metadata are basically two classes. FA2 in FA2 there is token metadata and change metadata, and 1.2 there are token metadata and contract metadata. Admin, again, you have administrator classes. Supply, you have mint and pause. And I think in FA 1.2 there is a mint burn. Okay, there is an error here. This is supposed to go there, but yeah. And possibility, you have possibility in both, right? So that's the implementation. Now, metadata is basically the information that is not directly used for a contract operation. Uh, it could be about the code of the contract, or like the interface, the versioning, the author, or it could be the content of, or the meaning of the content. So on the chain is just a token ID, right? But what that is supposed to signify outside of the chain is what is called the metadata. So there are different standards of metadata. There is a TZIP 16 standard, there is a TZIP 21 standard, there is a TZIP 23 standard. So there are different standards of metadata that you can look at. But I mean, all of the standards extend the TZIP 16 standard, so you should definitely look at that. The metadata is basically a big map, and the first key always needs to be an empty string, and its value needs to be passed, pointing to the location where the content is stored. And as I said, there are different ways of specifying the metadata. You should refer to TZIP 16 to understand more. So there are different tools that are related to development, tester, CLI, and GUI, which is basically developed here in India by. So you should check that out. It's basically, it lets you spin up your own blockchain, and it lets you deploy contracts, lets you do a lot of cool things. The SmartPy ID, we'll just briefly touch upon that in about a minute, if I think time persists. Taquito and Conceal.js are basically like Web3 JS like libraries that help you connect with the blockchain, interact with the blockchain, read from the blockchain, write to the blockchain, a lot of things, right? And Beacon SDK is basically an SDK that lets you integrate a wallet into your application, into your dApp. So Tezos supports a lot of wallets like Kukai or Temple. Temple, I think, is one of the most common wallets. So yeah, it lets you plug into these wallets into your application. So that is basically going to bring us to the end. I'm just going to quickly show you some uh, examples of how the contracts look like. But this is the FA2 I'm going to look at. Yeah. So yeah, while I look at the contracts, so this is how the contract looks like. I hope you guys have seen how what a SmartPy is and how it looks like. So it's basically an ID that you can use to sort of develop your contracts. It's very cool. It's got a lot of like cool features. You can it's basically um a simulation environment for. It's basically a library to begin with. It's a library for sort of constructing contracts, but. So of course, being like a Python library, it gives you a lot of benefits. Like you can use the entire power of Python and iterate over data structures, call other libraries, and pre-compute parameters, do all sorts of things on Python using this library. And the SmartPy is comes with, or I mean, is developed by the SmartPy team, who also built the SmartPy ID and the playground. This is a very cool tool to, it has compiler to compile your SmartPy code into Michelson code. It has a simulation engine which lets you simulate your program and test on it. It has a contract explorer, a wallet, a runtime environment. So it's got a lot of cool features. So you should definitely check it out if you already haven't. So this is the contract. This is the this is how you import SmartPy. You can, I mean, if you would have to use the contract, what you would need to do is you would need to import the SmartPy, import the FA1.2 or the FA2 contract, and then initialize that using the config. So I'm just going to show you how the config looks like. So this is the config that we spoke of. It takes in some flags. So let me show you the FA2 flag that will make it more simpler to understand. See, so if I just turn on the single asset flag, so currently this is false. If I turn this on, it becomes a single asset. So you don't have multiple assets here. If I turn this flag off, non-fungible, off, then it becomes a fungible asset, meaning that this is, so you would need this false and this true for it to be a single asset fungible token, right? For today's course, tomorrow we look at how to make it non-fungible, which, as you can guess, would be to turn this flag on, right? And this flag, what it does is it basically increments token ID by one, right? So consecutive token IDs are used. So this is how you would use config class, and then you've got different functions. So let me actually show it to you here. So you've got config class, and then you've got the core class that I spoke of. So let's see where the core is. So the core should be somewhere here. Yeah, so this is the core class. This is the core class. This is like the basic class. All right, so this has got three functions: transfer, it takes some params, and params is, as I said, it's a list of transaction object and a from. So there's a from and a list of transaction objects, as you see here. It iterates over that and does this. There's a balance off and there is a off-chain balance. So now there is an update operators. I'm not going to look at this today. This is beyond the scope. These are some view functions like is paused and is administrator. This is not a part of the standard, but of course is supported through inheritance. So there is an administrator class, there is a pause class, there is a mint class, and change memory. All of these can be used like this. So let me show you how they're used. So the FA2 class actually, uses all of these different sort of classes to create this whole configurable, customizable token contract. All right. And apart from that, it's got some views like what the total supply is some address and operator of a particular owner for a token ID, things like this. You've got all sorts of things here. If you run this, the tests that are here will run. Let me show you for this also. I would import it and then I'm going to run it. So once I do it, so this is the beauty of Tezos. You can actually run smart contracts on the SmartPy ID, and you can see things happening. So I create a test scenario, then I create some accounts, and then I create a token metadata, contract metadata, and then I create an FA2, right? So this is how I create an FA2 contract 1.2, and then I add that to my scenario, and that's it. That after that I keep playing with that, right? So it takes an admin address, the config. So in config, I have just turned on one flag. The rest are whatever the default value is, and I've supplied some token metadata and contract metadata. That is how you initialize an FA2, FA1.2 contract, and then you can call different functions. Like, for instance, you can call, let's say, the transfer. So Alice can transfer some value to Bob, and so on and so forth. So you can do all sorts of things. Just play around with this, and this will start making more sense. This is a simple contract as against the FA2, which is a more complicated setup. Still, it's not too hard. You should look at Crypto Wars. That's a brilliant tutorial for learning SmartPy and for learning the FA2. Yeah. apart from all the other resources that are mentioned here. You can check these out. I'll share this link with you. So yeah, so this is basically the contract, and you can see this is being the contract balance of mint set administrator. So here, if you see what we've done is we've created like the full FA2 contract. So we've actually used the entire contract, FA2 contract, which has the mint, burn, all the functionalities. And the config is basically uh, the default config. So we've just used that, right? So yeah, basically that's how it works. This is what it is. You can deploy it. So let me actually try to see if I can deploy it for you. So if I go to deploy metadata, so I'm assuming you've seen SmartPy. If you haven't, there would be a workshop on SmartPy. You can, check that out as well. So if you look at, you remember I spoke on SmartPy being a high-level language and much easier to work with. So, I mean, if you look at this, this is much easier to understand and work with, right? As against, let me show you the code so this is Michelson code. So you see these are all operators, swap, dug, get, if. I mean, it's very hard for me to understand, honestly. I'm assuming it's not a breeze for you either, but yeah, so instead of writing this, you can just write this. So this is the transfer operation, right? But if you see here, it's much more simpler. So that's why people prefer using, things like SmartPy. So now how you deploy a contract is like this. So you just go here and yeah, while I do that, I would open up for questions. So you can load a wallet. So I'm not going to deploy on mainnet. I don't have Tezos on the mainnet. I can probably deploy it on Florence or Edo. So I'm going to deploy it on EdoNet, for instance. And I'm going to use the Temple wallet. So it's going to, I have a Temple wallet installed. You can also use the, okay, I don't seem to have balance, but that's okay. I'll have to get some balance from a faucet. All right, I see some more questions, so how to set up a Tezos development node. How do we, all right, so Tezos development node, you can use the Truffle suite. Truffle also supports Tezos. If you use Truffle on Ethereum, you should be comfortable with Truffle. You should also consider using Tester, which we looked at. So Tester, CLI, and GUI, you should definitely check these out as well. This is how you can set up your own development environment and start playing with it. How do you mimic Web3 JS in Ethereum? So you don't need to mimic it. I mean, of course, the interface is different, but you got the Keto and Conceal JS, which are Web3 JS similar, like libraries similar to that. And uh, what are the live NFT marketplaces being built on Tezos? It's a good question, but it's a question for tomorrow, because tomorrow we touch upon non-fungible tokens. There are a couple of NFT marketplaces. One of them is called Kalament, made by a good friend called Sandeep. So you can check out Kalament, is one. There is another one called, I'm not sure how to pronounce that. I can post the link sometime. There's another one that we're working on. It's called TezAuction. I happen to be the creator of TezAuction, so you can look at TezAuction as well. And yeah, so there are a couple of marketplaces on Tezos, so you can check them out. So yeah, Kalament and TezAuction is something you can look at, and there is another one which I keep forgetting. I can drop the link maybe after the presentation. All right. So another question I see here is, so we can use Python for creating smart contracts on Tezos. Yes, if you use the SmartPy library, you can use Tezos. You can use Python. You can write your smart contracts in Python. Yes, correct. All right, so that's all. That brings me to the end of my presentation. Uh, you can contact us on Telegram or on Discord or on my mail. And this is my Telegram handle. This is the Telegram handle of our India channel. You've also got the link to our APAC Telegram channel. You can join that and also the Discord server. If you've got any more questions, I'm ready to answer those, here to answer those.
Hi. Hi, and thank you, Mr. Moody, for your wonderful presentation on the workshop on fungible tokens. So if there's no other questions, there's no other questions. We can end off this workshop. Thank you so much, and you can find all the resources and most of the things on Discord. So in about 10 to 15 minutes time, we will also have like a ice breaking session so that you guys can also discuss about what has transpired during this workshop. So thank you so much again, Mr. Mundi, and have a nice day.
All right, guys, have a nice day. Cheers. Bye bye.